Okay, so for number 6, we have a colorimetric analysis. And we get this wavelength chart. Okay, so here the question is basically just asking what's the optimal wavelength where you should measure this solution. And so the key here is the more absorbance there is, the better reading you're going to get, obviously, right? Because the solution will reflect more of the light. So what's the optimal wavelength? Yeah, 525 is where the peak is. The peak is right here. So the optimal wavelength answer will be 521 nanometers. That's it. What's up? What?
You said 521.
Did I? I thought I said 525. My fault. 525. Guys, it's been a long break. 525. My fault. 525. Okay, so if you guys ever see a graph with absorbance, the peak of that graph is the best absorbance, and that's the wavelength that'll be best to do that experiment. Okay, easy peasy, right? All right, let's move on to the next part, part B. This one's really easy. Number 1 is just asking you what's the measurement for in the graduated cylinder. Okay, and so what we always want to do is we want to look at the bottom of the curve. It's called the meniscus, similar to like the part of your knee. So this is 91, 92. So the volume that the student should record is 92 milliliters. The key is always look at the bottom of the curve. Okay, the meniscus. All right. So that should be pretty easy. So I'm going to give you guys about 2 minutes to try out part 2 of B2. Okay, you're basically going to be calculating the volume of this solution that's required, or the amount you need to produce the second solution right there. Okay, so it's a dilution problem. So I'll give you guys about 2 minutes to do that, and then we'll go over it together. Okay, so since this is a dilution problem, the formula we use is M1V1 equals M2V2. It doesn't matter which one you use as long as they stay together. So we want the volume of this solution right here. So I'm going to make that my M1. If you made that your M2, that's totally fine. Okay. So that's my molarity. And we're looking for how much volume we need of this in order to produce 100 mils of the other one. 1.6 times 10 to the negative 3. Okay, and then so you calculate that out, and you should get 700 or 70. Whoa, 70 mils. Yeah, I'll leave this up here, and it's recording, so don't worry. Yes. Yes, that works too. Yeah, so there's other ways to do it, like with moles and stuff, and feel free to do that. But I think dilutions, this is probably the easiest. Okay. And I don't think this formula, yeah, it's not on the equation sheet you'll get. So you'll just have to memorize it if you like this, but I think it's a pretty easy one to remember. All righty. Yes. You good? Okay, for sure. Let me know. Okay, guys, shall we move on? We shall. Okay, we shall move on now. Okay, so basically for this next part, it tells you like the steps that the student is going to take. So you're going to make a couple standard solutions with dilution, and then you get something called a cuvette, which is basically just a little container that looks like this. And then you rinse it with distilled water, and then you distill it with the standard solution, so the compound that you're using, and then you fill it up. So first, you rinse it with distilled water, then you distill it with standard solution, and then you fill it up, okay? And then basically you put it in this machine, and it shoots light into it, and then it sends out, it refracts the light, and then you get that absorbance peak from that, okay? That's basically what this situation is saying. All right, so it tells us that this right here is what's produced. This is a chart that's produced. And if you guys notice, there's one thing that's off, right? There's one data point that's not with the curve. The question is basically asking us to find which one of these steps would the student have to mess up on in order to get that error right there. Okay. So I'm gonna give you guys about 2 minutes. You can talk it over with the person next to you. Just pick one of the steps. Which one you think is going to produce that error. Try to write a justification. We haven't really talked about this, so if you get it wrong, don't feel bad. But just try to use your best judgment. Which one of these steps would the student have to mess up on in order to get this curve right here? Okay, and then we'll go over the answer in a sec. Okay. No, I believe you. I believe you. So yeah, that explanation was perfect. So if you guys take a look, I'm gonna go a little bit more into. Hey guys, take your marriage problems outside. Okay. So I'm gonna go a little bit more in detail, but if you guys take a look at this, the anomaly, right? This point right here. If you guys notice, the absorbance is a bit lower, right? So tiny bit lower. So if the absorbance is lower, that means that the solution is probably a little less concentrated, right? Because if there's more stuff in there, it's going to absorb more, obviously, right? Yes. Yeah, so let me get into that. So since this one is a little bit lower, this basically tells us that the solution is a little bit dilute, okay? So that means it's not as concentrated as it should be according to this plot. So if you guys take a look at the steps, like Brendan said, it's going to be step 3. And the reason why is because the student probably did not rinse the cuvette with the standard solution. Because think about it. If you rinse it with water, even if you pour all the water out, there's still going to be a little water left over, right? And that little bit of water will dilute your solution, and then it's going to lower the absorbance. Okay, so that's going to be the answer. So if you guys want to jot this down, I guess I can write it out for you. But the answer is going to be no. Step 3. And it's because if you don't rinse with standard solution, it will dilute the solution. Okay. That's it. Super simple. And if you want to go more in detail, which results in lower absorbance. Okay, just something along those lines. All righty. And that's number 6. So that's a short FRQ. Woo! Good job, guys. Good job, Bradley.
Yes, no, this is okay. Normally I do still, honestly, but no, this is the first time I did it. No. Okay, yeah, for the other time.
Hey, she didn't have her name on that answer.
Exactly.
Yeah.
Thank you. He said, I wonder what Lorenz.
Watch him get a 5.
There's a
He's on the news. He's like, there's one student that got 100% this year.
There's a higher chance of aliens landing on the Earth.
You can do it. There's 0 chance of that happening.
Exactly.
Wow.
You can do it. I don't think there's a possibility for aliens to exist. The possibility of life starting on Earth is already too low. So we're already an insane anomaly.
The vast galaxy.
Yeah.
Galaxies.
All right, so we have this compound right here. Now, first thing we got to do is find the hybridization of the orbitals on either carbon atom. Now, it's probably been a while since we looked at this, and you guys might not remember. I'll give you guys the answer just for the sake of giving you the answer, and I'll explain it, but this is something that you'll kind of just have to memorize on your own. If you guys look back at the modules on Canvas, I have that chart for you guys. But both of these guys have sp2. Okay, that's going to be the hybrid orbital. And the way that we can tell that is because each of the carbons has 3 electron groups. Okay. Okay. I know it's stressful thinking about this. So you got one group here, one group here, one group here. Another way you guys can look at this is the geometry. Anyone remember the geometry name for this carbon right here? Planar. Yeah, trigonoplanar. And it's because it's on one plane. It's like a flat triangle. I know it's we haven't looked at this in a long time, but I'm just giving you guys a heads up. It might be helpful to remember this, to look back at this stuff. But yeah, that's how you can tell. You can look at either the geometry. I like the geometry a little bit more than the groups, just because, as you know, I'm a visual person. But if the electron groups work for you, that's how you can memorize the hybridization. Okay. What is he listening? Yes.
If you only put like negatives, you get like half credits.
No, this one there's no half credit because just asking for the hybridization, they don't care about the justification. You just need to give them SP2. Yeah, unfortunately.
So, okay, can you remind me how that FRQ grading works? Because like, is it like you get a point for A, B, C?
So I'll put the answer key online, but yes, it's gonna be a point for like A, point for B, 2 points for C. Yeah, they're broken up.
But you don't have to get like all of them,
Yes,
right?
that's correct. Yeah.
Okay,
That's correct.
that's great news.
Great news.
That's great.
Alrighty, guys. Let's go to part B now. So it tells you that you got silver oxalate, and you got the formula right there. And it's slightly soluble in water. So if something is soluble in water, it means it's gonna partially dissolve, right? So if something partially dissolves, that means it's gonna go into equilibrium. So that means the equation is gonna go into this, and it's gonna dissociate into 2 Ag ions, and it's gonna dissociate into 1 oxalate ion. Okay. So it gives us a KSP value, but for part 1, it wants you to just write the KSP expression. Okay, so hopefully this is a little bit more fresh in your brain. So I'll give you guys about a minute. See if you guys can write the KSP expression for this equilibrium. If you guys ever see solubility, you can kind of assume that it's going to go into its equilibrium, okay, or slightly soluble. Okay, so hopefully you guys remember that the KSP expression is going to be products divided by the reactants. So it's going to be the concentration of Ag plus, but since the coefficient is 2, you got to square it. And then you got the concentration of oxalate, but since the coefficient is 1, you could leave it. And we don't care about the pure substances, so we can ignore anything on the bottom. So that's it. Woohoo! And that's equal to 5.4 times 10 to the negative 12. You didn't need to write this part right here. I'm just setting that up for you guys. Yes.
So to get the point for C, would we have to get I and
No, they're separate. They're all separate.
Okay.
Yeah, so there'd be like point for 1, point
Yeah.
for 2. Yeah.
Okay, good.
Yeah. So it's like split up in every section. All right. Any questions? All right, let's move on. Okay, so for molar solubility, this is pretty simple. What you're gonna do is you're gonna take the KSP expression, so 5.2 or 4, 5.4 times 10 to the negative 12, and we're basically going to set the concentrations of each of these to x. Okay, so it'll be x squared and then times x. Thank you, 2x squared. My fault. Oops. I'm sorry. I'm sorry. Okay, and then all you got to do is solve for x. That's it. That's how you find the molar solubility. Okay, so I'll give you guys the answer. If you guys want to punch into your calculator just to see if you guys can get it, it's gonna be 1.11 times 10 to the negative 4. The key here is you got to square this, so it'll be 4x squared times x, so 4x cubed will be what's on the right side.
Is X equal to the molar solubility?
Yes. Because it's 2 Ag ions. You still got to include it in for the molar solubility because you're releasing 2 per. Yeah. Alrighty. Oop. Any questions on that one? Boy, not too bad. Okay. Move on to number 3. Okay, so number 3 is a little bit annoying because there are multiple answers that you can get. So I'm going to explain kind of what's going on, and then I'm just going to put the answer key up, and then I'll have the answer key for this FRQ posted at the end of class as well, okay? Okay, but it's telling us that the molar solubility of silver oxalate, it increases when it's dissolved in this solution instead of neutral water. And so basically it's asking us to write the balanced net ionic equation for the process that occurs between this in solution that contributes. So basically what increases the solubility, okay, because it tells us the solubility increases, and we have to write the reaction that kind of supports it. So there are 4 possible answers. I'm going to put them up on the screen right now. Okay, and so any of these will work. Okay, so you guys don't need to write this down again. I'll put this up on the website on Canvas. I'm not going to spend too much time, but basically what you need to write is that you have the oxalate ion, and it's going to react with the water, or H+, right? So the acidic component of water, and then you just need to balance that equation, and these are what comes out of it, okay? So again, I'm not going to spend too much time on this. I'm going to put it up on Canvas so you guys can take a look at it and just kind of think about how that works. But the key is you have to have the oxalate ion, and it's going to react with the acidic component. Okay, and then you just need to balance the equation from there. Okay. That's it. Yes.
Why is it like one is one, like why does it?
Yeah, so either of them can work. That's what it's saying. It's because the hydrogen ion that comes from the other compound, so the new solution, HClO4, it's a strong acid. It's going to release H+, 100% dissociation, and this is going to be what reacts with this, and that's what increases the solubility. So you can either do the monoprotic reaction, or you can take it to the second step as well. Either works. Yeah. If you want to talk actually chemically, this is what's going to dominate the reaction. This is going to be the most common one, but this one also works too. Yeah. Yes. This would be like the second step.
Yeah.
It's that, but then because you can do either one, that's why they give you the multiple options. Yeah, but good question. Okay. All right. Any questions? Other questions on this? Basically, strong acid forces the reaction. Yes. Yes, that's correct. Yep.